This is the continuation of today's lesson. We're finding the payment for the present value of an annuity. Now, originally we started with this equation for the present value. This basic equation where we have our residual R, our P meaning how much our annuity is worth today, which is called the present value, and everything else stays the same, just like in compound interest. Now what we'll do is we'll rearrange this equation by, instead of dividing, multiplying I and then dividing by 1 minus 1 plus I to the n to find R. And we get the following. And we get this. This makes calculating the R value, or the deposit, as easy as what we used to do before when we calculated the R value for the future value. Now, let's go through this problem and try to identify what we're looking for. It says here, Karen won $500,000 in a local lottery. She decides to invest all of the money today and make monthly withdrawals over the next 25 years. If the interest will average 6.3% compounded monthly, what withdrawal can she make? So let's go and make an aside here. Let's think about all the different things that we're looking for here. First of all, the $500,000 that we have here is basically going to be an important thing. So let's go and identify that in blue. So the $500,000 is being invested today. And it's just going to be sitting in a bank, and we call that the present value. Now, since that's the investment and we've decided it's just going to sit there as a present value, it says she decides to invest all of the money and make monthly payment withdrawals. So basically what we're going to be doing is we're going to pull out that money for the next 25 years, and we're going to do that every month. Now, let's start by taking a look at the idea that we have a withdrawal. So if they ask for withdrawal, we have to use this basic equation. So firstly, we identified the present value. The present value ends up being 500,000. So let's fill that out. The next thing that we have here is our interest. Our interest on our thing that we're looking for turned out to be 6.3%. So that's 0.063. And now that's for a year, but we have to bring it down to 12 months, so we have to divide by 12. Then also we also have withdrawals over the next 25 years, which is just going to be 25, but then it's going to be multiplied by 12 because we have to change our n from years into months, which ends up being 300. So now let's substitute the rest of that in, and we get this substitution. So now punch that into your calculator and you're going to get your R value to equal. So now you end up with 3,313.82. So therefore our final statement would be, so she can withdraw $3,313.82 monthly. Now let's move on to the total withdrawals under the plan. So if you think about it, the total deposits that we did before is going to be exactly the same as the total withdrawals under this plan. So in order to do that, we do the following. We say our total is equal to R times N, which is just 3,313.82 times 300, which gives us the following. $994,146. And we basically do our final statement. Now, let's move on to question number 2. So just like before, we're going to use this basic R calculation. All right, now a new car which costs $18,900 today can be financed over 3 years, right? At a rate of 2.9%. Let's go and identify all of the things that are in here. So because the car costs $18,900 today, that's what we call the present value. So this is the present value. Now, that's it. It asks us to find the monthly payment. So let's just use our R equation. Pause the video and then do the calculations for this. Let's see what you get. I'll put the solution online and then you can do your homework. Punching this into your calculator, you get your R value to be 548.80. We identified P, we identified 3 years, it was monthly payments, and our interest rate was 0.029 divided by 12, and we're done. Your homework is part of the package that's online.